I'm Dr. Daniel O'Neill. I'm the Center Agreements Manager in the Partnerships Formulation Office at Marshall Space Flight Center. I'm proud to be supporting the International Space Apps Challenge for the 9th time. This year, I'm pleased to present to you a challenge to create an Orrery web app that displays near-Earth objects. What is an orrery? Well, back in 1712, John Rowley made a mechanical model of the solar system, and he presented it to Charles Boyle, who was the 4th Earl of Orrery. And since then, such models of the solar system have been called orreries. So this year, the challenge, if you choose to accept it, is to create a web app that's embedded in a web page, and that web app should display a model of the solar system and include near-Earth objects such as comets and asteroids. The resources page for this challenge provides a link to a NASA GitHub repository that includes exemplar web apps and tutorials. As an example of one of the web apps, here is a static orrery. Static meaning that the planets aren't moving around, but the model is interactive. You can turn it around and you can zoom in and out of the model. A feature of this web app is that it includes a table with Keplerian parameters for the planets. Named after the astronomer Johann Kepler, the Keplerian parameters define the shape of an elliptical orbit. Another example is this dynamic orrery where the planets are moving around the sun, and it includes potentially hazardous asteroids. And features of this web app include the ability to toggle the labels of the potentially hazardous asteroids, or PHAs, and then to toggle the orbital trajectories. Also, it has a timeline where you can slow down or speed up the propagation. An orbital propagator mathematically determines and updates on a periodic basis the positions of the planets and the asteroids. To learn more about Keplerian parameters and how to develop an orbital propagator, there is a tutorial that's linked to the resources page. And this tutorial provides examples written in the R programming language, and it starts out with a flat ellipse, and then it explains how the various Keplerian parameters will rotate that ellipse around the various axes. And it includes interactive models so that you can see how the ellipse gets rotated about various axes, and then shows how to have that positioned around a body. And then it includes an example orbital propagator written in R, and then it's got an example that you can actually play where it shows the propagation. So with that, I hope that you will consider accepting this challenge. It will give you and your team some hands-on experience in the development of a web page with an embedded web app. Also learn about Keplerian parameters and orbital propagation and working with NASA data. It's really important to deploy the web app so the judges view it. The Space Apps judges cannot download code for security reasons. If you use an existing code base to build upon, that's great. Just make sure that you acknowledge it and provide a link to that code base. It's okay to use artificial intelligence, provided that you document the prompt and provide a link to the application and maybe describe a little bit of the process. During the event, I hope that you'll join in on the discussion forums, that my fellow subject matter experts and I will be in those forums where we can answer technical questions and brainstorm ideas with teams. I look forward to interacting with you through the forums, and happy hacking.